Hello. Hello. Can you hear me?
Uh, mhm.
Hello.
Hello.
Yeah. So your voice is very slow. Kindly speak louder.
Mm, Yeah, you can hear me.
Yeah. Yeah. So now part.
Yeah.
Oh, okay. So in this time, I will show you this algorithm. Mainly, what is the method in
Okay.
this code I follow. I will explain about this methodology. And further, if you want, you can easily take it, and then you can easily make this pro classification about that. Okay. So in this
Okay.
time, I will talk about that multi-class pro classification. Suppose at the same time we try to classify it for rice, sugarcane, or jute, or other types of crop at the same time. It's called the multi-class crop classification. Okay. So let's go. I simply share my screen and then try to show you this process or method. Let me share my screen. Okay. So now can you see my screen? Is it visible?
Uh, yeah.
Okay. So here you can see. So basically, it's one kind of our project work for the crop classification in the Punjab, in Pakistan, and we
Yes.
already complete this work. And mainly in this time we just try to in our work for year of 2017. Okay, in 2017 we try to classify it for the rice, cotton, fodder, maize, sugarcane, and wheat crop for the Punjab in Pakistan. So basically, in this time, what we can do, I will explain it. Then you can easily get about the method. Okay? And here we can find out the accuracy about that 71% accuracy. Okay. And first of all, here you can see you have to import it your agricultural land. So in this time, in our CSV file, or this is our shape file. Okay. So point shape file for each crop. Which crop you want to classify, such as rice, cotton, fodder, maize, sugarcane. So all of crop we try to add in here. So basically here you can see the zero. So basically it's our class level. Suppose zero for rice, then one for cotton, two for fodder, three for maize, four for sugarcane, five for wheat. So it's our class level. So in this time, we take some training sample. Okay, so basically this training sample, it's more better when you want to take the ground training sample. You simply go to field and take this training sample of each crop classes. Okay,
Okay.
further, yeah.
1 minute. These crops are just like a polygon or just like a point.
Point.
Okay.
As a point, we take the some training sample for our is crops. Okay,
Okay.
and further we set the level. Suppose you can see zero, it's one kind of level. So zero mainly it store it only for the rice. Suppose
Okay.
one for cotton, two for fodder, three for maize, four for sugarcane, five for wheat. So this is our class level. We set the some level because in this time we are applying the supervised machine learning method. And when you want to apply the supervised machine learning method, you must need the pre-categorized data. So this is our pre-categorized data or of each crop classification. Okay. So if I print that, then you can also get the more better. Suppose I just simply print this agriculture because this variable stored all of uh, point point of is classes, then you can get the more better. Just I run the code again. Okay, so here you can see we can get the first code. Here we take total 1390 points. Okay, and you can
Okay.
see the feature. So basically it's our point shape file for each crop. Okay, you can see the
Okay.
point, it's a point. And further, suppose I click on here, suppose I want to check about this point. Here you can see it show the class 1. Okay, so class 1, suppose it's one, this is the label. Suppose for cotton, 0
Okay.
suppose rice, 2 for
Okay.
fodder, 3 for maize. So all of things we try to add the class. Suppose I want to check what is the class about that. You can see this class is the 3. Suppose this training point I use for 3. 3 can is one kind of level. So it can be sugar cane or it can be mice. So when you want to take the training sample of each point, you can simply put the label. Suppose all of 0 training sample, it's just a rice. All of training sample, it can be cotton. All of training sample for 2, it can be fooder. So it's our label. It is this,
Okay.
it's a shape file, it's a point shape file, and this point
Okay.
shape file is stored the different types of crops point as well as also their label. Okay. Okay, so
Okay.
it's okay. So it's a main condition when you want to make the your crop classification for your own study area. You have to also take the training sample of each classes and then further take the label and also make the shape file and import the shape file in here. Okay, after doing these things in this time, we are just in this time here you can see we take the season wise. Suppose you can see the January 1st January to December 28th. So it's one kind of season for the crop, as well as we also take about that the another season. You can see 3 to 4, mainly March to April. We take the another season. Also, you can see about that. We also take about that 5 to 6, mainly May to June. We take the another season, and all of season we create the median composite. Okay, and further we make the also you can see 7 to 8. So it's the another season we create in here, and further we are also make about that you can see 9 to 10. Okay, as well as we also take the 11 November to December, as well as we also take about that you can see, and further all of monthly. Suppose 2 month we are just make the March and create the final image collection.
Okay.
Okay, so image 2, image 3, image 4, image 5, image 6. So basically it's the individual period. Suppose image 2 is the January to December, then image 3 is the March to May. So this is the our season wise. Suppose some crop are available for seasonally or seasonal crop. Different types of season have cultivated the different types of crop. So that's why we are also making the different types of season wise crop, season wise image collection for median image collection. And further we are also applying that calculate the NDVI because it also need for make the crop classification. So that's why we can easily find out for each crop what is the condition for the NDVI value. Suppose rice and cotton or fodder or maize, it has some distinguish between the NDVI pixel value. Suppose for the rice I find out the 0.5, but cotton I can find out the 0.3. So it create the differentiate. This pixel value of NDVI create the differentiate of each classes. So that's why we can easily classify it. This is the rice, this is the cotton, this is the fodder, this is the maize, this is sugar cane. So that's why we also add the one band. It's called we calculate the NDVI. Okay. So NDVI pixel value create the differentiate of each crop classification.
Okay.
And further, okay, and further we also try to add here this type of things here you can see. I'll also show you the layer. Suppose this is our final crop classification. And here you can see in this time, this is the red color point here you can see. This red color point identify about the different types of crop. Okay, different types of crop it's identified. Suppose this is my training point, agriculture. This variable stored the all of agricultural points for each shape file. Okay, so this is our training sample. We take the training sample only for this study area, but we classified for the whole Punjab. Okay, so in this
Okay.
time you have to also create your own shape file for the point. Suppose this point, this point, this point, and also create the label above all of each point. So that's why suppose this point we can easily get the label class 3. Suppose it can be fooder or mice training point. Okay, so after that in this time we also take the some external. In this time here you can see we also take the some training sample for that barren land, also take the training sample for the urban, water, forest, grass. So it's another part because in this time this type of training sample we extract from the satellite image, not use the ground sample. We are just simply open the satellite image. Here you can see, so suppose this is the one kind of satellite image, and from this satellite image I just extract the barren land, take the training sample for the barren land, then urban, then water, then forest, then grass. Okay, basically these
Oh,
things we do for differentiate. Suppose grass and forest, it can be mixed with our agricultural land pixel, so that's why we create the another class for the grass and forest, as well also water, urban, barren land. We also try to add this type of training sample from this satellite imagery. Okay, so how we can easily get it? Very easy. Simply click on the layer button, and then you can easily take the training sample here. Simply click on here. Here you can see it. So the value 6. So in this time, all of barren land class, we set the value for 6. Okay, and also take the training sample for that, yeah, urban, water, forest, grass, and this type of training sample we collect from the satellite image, not ground sample. Just we simply use the different types of band combination and take the different types of training sample for each classes, for the barren land, urban, water, forest, and grass. And these things you must do, because if you don't classify this type of classes, then this is the chance to mixing. Suppose cropland rice is mixed with the grassland, or rice mixed with the forest. But when you make the differentiate class for the grass or forest, then it not chance to mix with each other. Then we are also get the more correct crop classification map. So that's why we are also make the differentiate and create the different class for the forest and grass, and also water body, urban, and barren land. Okay, and after doing these
okay.
three things, we are just march all of training sample. Here you can see march all of training sample for that water, forest, urban, agriculture, barren land. Okay, so in this time, grass, barren land, also you can see the urban, forest, this water. So this type of training sample we collect from that satellite image, and only
Okay.
the agriculture, basically which including the different types of crop, it collect from the ground truth sample. Only ground truth sample we are just using here in the agriculture. Okay, further we are just seeing that we can get how much image how much training sample we can collect from here. You can see. So basically in this time we just use here. Okay, so here you can see this is the result about that. We just use here this 1984. Okay,
Okay.
this is our total training sample for each classes. Okay, let me open that. Suppose I click on here, I check what is that properties. You can see the class 8. Okay, so in this time, all of sample water, forest, urban, agriculture, we are just merged and stored in the sample variable. And further, we are just apply the extract the band pixel value, and we are also use here the 70% data for train our model and 30% data for test our model. And further, we are just applying the random forest machine learning model, and then train our model, and we can get the train accuracy, and also just try to make the classified imagery. So just I simply try to open that random forest. In this time, this is the show all of classes, mainly your all of classes. All of classes including. After doing these things, after make the classification, I want to show only for that crop classification. Okay, so here you can see I just call here the classified RF 6. Okay, 6 is mainly our class value for that. Okay, so you can see now it's about the marks with the crop. Okay, so then we are just try to show only for the crops layer. So just open that. Okay, so now you can see here we can get this type of map look like that. It show only for the crop land. Okay, different types of crop. Here this type of red color identify about the wheat area or wheat crop. Also you can see this type of color sugar cane. So this is the sugar cane, as well as also you can see the maize. So this type of green color identify about the maize. We can get this is the area for the maize about that. Also fooder, some region also get the some cotton, this type of region. Okay, you can say
Okay.
cotton. Basically,
Um,
this type of region you can find out this type of region, cotton,
okay.
and
Uh,
also get the rice.
yeah, I
Yeah,
have a
please.
question that because in Pakistan, the farmer look like that they are doing such a practice that after harvesting the rice, they sowing the wheat at the same field. So how we can differentiate that? Because our rice season is different from the wheat season. For
So which?
example,
Yeah.
for example, in your map, I can see that there is a no rice because most of the like a wheat and the maize and the sugarcane and the cotton, but the rice is not enough because in this area at this time there is a wheat, not the rice. Because after some time, when they will harvest the wheat, they will sow the rice crops. So maybe at the same year, we cannot show the wheat and the rice at the same
Yes,
field.
yes, 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 yes. So it's another question because at the same time, a wheat and rice is not possible. But for this
Yeah.
project, they are called about that at the same time. They are show the rice and maize. So that's why you can get this type of problem. Okay. So when you want to do it, so you just try to make the season wise. Then you can just take only for the rice or also or take only for the maize. Then it will be okay, I think. Yeah. Otherwise,
No,
yeah.
it's just like a rice and the wheat, not maize. Because maize is also common because every month, every 3 months, the farmer harvesting the maize because it's almost 3 times in a year or sometimes 2 times in a year.
Okay, so in this time in here, they are take the whole year imagery. You can see they are put the image collection for the 1 year. Okay, 1 year they are make the image collection. It's the 1 year. Suppose you can see first of all we are just put here the January to February. Okay, as well as also you can see the and make the median image collection image one. And further also you can see about that we take about that uh, March to April. Okay,
Okay,
and make the
okay.
image two collection.
So for every month we have collect the image.
Yes, and also you can see the 5 to 6 and create the image three median image collection. And finally, for we take the image for image four. You can see the 7 to 8 month, and further 9 to 10, and further we put here the 11 to 12. Okay, and
Okay,
further we take the one suppose image two, image three, image four, image five, image six. Okay, we create this image collection in here. Look like that, and then finally when you run our model, we are use the image. You can see in the train image basically we are using the train image mainly image. Okay, so you can see this variable stored the image collection. Let me open image. Okay, so basically in this time it create this image collection for image 2, image 3, image 4, image 5, image 6. So basically in this time it consider all of season. Suppose image 2 it is the another season, image 3 is the another season, and create this collection and store it in here. And further we are use this image and make this classification. In this time image 2, what is the image 2? Image 2 is mainly you can see image 2 is the storage for the February to March. Then image 3 is the April to May. Then June to July. Basically this is the 2 month create this one image median image collection. Okay, and further all of image collection we are just stored it in this variable and then create this composite, and further this composite we are use and make this classification. Okay, if you want you can also do for the season wise. So for that you have to classification only seasonal image. Suppose this season, suppose January to December, this time which crop are cultivated, you can just take this training sample and also take this same date or time period image collection and then make this classification. Then we can get the proper result about the classification. But in this time, we are make the classification for all of image, all of median image collection. Suppose image 2, image 3, image 4, image 5, image 6. Okay, image 6. You can see image 6 is mainly stored for the image collection between this time, year of 2017, November to December. Okay, so November to December composite stored the image 6. So I take the image 6, also image 5, image 4, image 3, and image 2. Okay, and make this image final image collection. Okay, and store it in this variable. And from here, we are just calculated that NDVI using this image collection, and further we are just use this IMG. Basically, you can see this image. This variable is stored the all of image collection: image 2, image 3, image 4, image 5, image 6. Okay, and further when you run our model, we are just use here the IMG, and then we are just use it to make this classification.
Okay. Can we calculate the area of each crop?
Yeah. Further, we can easily calculate the area, how much area for the each crop, as well as how what the accuracy about that we can get. Okay, in this time we can get the 71% accuracy. So basically, it is a multi-crop classification. So 71% accuracy is also enough, because in this time we at the same time for the different types of crop we classified, as well as we can also you can see the download the tip images from here. Okay, so this crop classification we can also export it as a tip format, and further process we can easily make the crop classification map using ArcMap software or QGIS software. Okay, and further we can easily make the calculate the area in ArcMap software, a simple process.
So we can also import this picture we can also import this picture to in our GIS in a like a TIFF form.
Yeah, so just simply run it and then open it ArcMap software, and further you can easily create the crop classification map, as well as calculate the area, how much area is available for that.
Okay. So you have for crop classification you have only 2017, and we can start from 2000 because Sentinel data is available from 2017 to 2000
Yeah,
go on. So okay. So it's you have used random forest machine learning model for
yeah,
this
random
crop
forest. Yeah,
classification, and kappa coefficient is around about 0.71.
yeah.
Okay. Okay. If I want to show, if could you please show me the rice? If I want to show that in my field, I want to show that no, the wheat is harvesting, and I want to show the rice.
Suppose you want to show only for the rice area. So for that, let me show. Suppose I just simply take a variable for rice. Suppose yellow color into showing rice. So then it's about the one class. So now it shows some about that. So this is the one kind of prop. Okay. But what's the
Uh,
level? I don't know what is the one level. So you have to
I
check
think
about from the shape file. When you take it, you are just remember that 0 is that this crop, 1 is this crop, 2 is this crop, then we can easily differentiate. Just we
yeah.
put here the equal to 1 or 2, 3, 4. It automatically show about this that only for this class. Suppose when I put here the suppose I put it the 3 and then check or the 3. Base 3 is the level, and this level is stored the one class of agricultural land. Okay, so now I can get this type of area. You can see this is the another crops. Okay, but what is the level about that? You have to check about the level. Suppose 3 is can be suppose cotton or food or mice. So when you take the training sample, we have also set about the level 0, 1, 2, 3, all of crops level in our shape file. Okay, suppose you can see agricultural shape file. It already stored the level about the 0, 1, 2, 3, and we have to remember about that what is the 0 class, what is the 1 class, what is 2 class. Then we can easily differentiate about that. So basically this is the code. This code you can easily use your and modify it. Suppose you are just working for only for the one season, then you can take only for the one median image collection. Okay, and also take this training sample and work with that. But in this time, in this project, we work for the 1 year 2017, all of crops, not for any specific season wise crops. We consider all of crops and then try
So
to display in here. So
okay.
that's why we make this image collection and
So
combine all of image median image collection. We combine.
okay. So if I want to further calculate the 2017, 19, and 20, so I just change the year by year.
Yes, 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 yes.
Okay, okay, okay.
So basically, it also better if you have the some knowledge about the Google Earth Engine, then you can easily modify any code. Suppose when I
Yeah, yeah.
give you this code, you can easily modify and you can easily use it for your own study area. You can easily do it, no problem. So you try
Okay.
and further face any problem, then I
Yeah.
also guide you, no problem. You try
Okay,
and get the
okay,
code
okay.
and try, no problem.
Okay, okay. Actually, I also need this sample because uh, if you could provide me, it will be a more benefit for me. These samples, crop samples.
Yeah. So for this sample, you can collect from ground and further make this shape file. In this shape file, you including the all of samples level. Suppose all of you can make the one file. Okay, you can see in this time it's just a one file. Okay, this file we including the one column name is the class. You can see I will simply open the attribute table. Here you can see it's so the one column, it's called the class. So class, you can see 0. Okay, so 0 is one kind of level. So 0, I just suppose all of latitude, longitude 0 for that rice. Then 1 for that other crop, 2 for the other crop. So in the in one attribute table, all add all of classes. Okay, suppose
Okay,
0 training sample for the rice to one training symbol for that other crop. Okay, and further convert it as a point shape file
okay,
from the
okay,
coordinate or latitude longitude, simply convert into point shape file. And further these things we are just importing in Google Earth Engine platform. You can simply go to the asset and you can see about the new and you can see about the shape file. Okay, simply import this your point shape file and then import it in here.
okay, okay, okay. Uh, okay. Thank you so much.
Okay. Okay, you try. I hope you can easily got it. And further, when you want to work, face any problem regarding this code, I will guide you. No problem.
Okay, okay. Thank you, thank you,
Okay.
thank you.
Okay. Thank you.
So,
Yeah.
uh,
Tell.
Okay. You will also provide these samples.
Yeah, I also provide the all of things. I also provide the sample. Basically, this is my training sample. I also provide you. You can get the full code. We see
Okay.
showing this time. You can get the full code. Further, you can just modify according to this code and work with that. No problem.
Okay. Okay. Thank you. Thank you so
Okay,
much.
thank you. Okay,
Okay.
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 Have a good
Allah
day.
Hafiz.
Allah Hafiz.
Okay. Allah Hafiz. Thank you.